In this lesson, we're going to talk about something that is a little bit weird. They're called slope fields. So what we're going to see is a bunch of different tiny little slopes. So they're like the slopes of the tangent line to the graph of f. But we're going to take into account the differential equations that we saw back in the previous section, where we took the integral and then we found c. Let's talk about the definition of a slope field here. A slope field is a pictorial representation, so a picture, of all the possible solutions of a given differential equation. So the differential equations were like the dy dx equals. It's the same thing as f prime of x, because dy dx is the derivative of y with respect to x, or the derivative of f of x. Cool. So the solution to a differential equation is the function f of x or y, either one. That's what we did in the previous section. There is an infinite number of solutions to a differential equation such as this. Show your work and explain why. So I've already got this one written out. I would suggest just kind of watching and listening and then copying down or reworking it yourself as you pause. So let's start with trying to get all the y's on one side and all the x's on the other. So we move this dy dx, move the dx portion over to the right. So we get the x minus 1 dx, and then we take the integral of both sides. So we separated by multiplying by dx, and then we took the integral of both sides. When we actually do the integral of 1 dy is just y. And the integral on this side, increase your exponent, divide by 2, make that one an x, and then we normally put plus c at the end. Now, if we are not told one point that is on that line, or in this case, parabola, we can't actually figure out the particular solution that the problem wants us to find. This is called the general solution. So this function right here, f of x equals 1/2 x squared minus x plus c, is the general solution to this. It's general because c is a constant. We just don't know what the constant is. So there's an infinite possible number of solutions that c could possibly be. If you think about it, this guy right here is going to be your y-intercept. So if c was 0, that means your y-intercept for your function is 0. If c equals 1, that means that your graph is just slightly shifted up. If c is 2, it's slightly shifted up from that. C is 3, slightly shifted up. Wow, that's a tongue twister. All right, so the plus c means that there is an infinite number of solutions. The shape of the graph would be the same no matter what the value of c is. It's just shifted up or down. Okay, at this point, if you want to pause, rework this problem on your own just for some practice, we're going to still have c in our answer and then copy down whatever you need. All right, now that you have all that written down, I'm going to show you what a slope field looks like. Do not copy this down. We're going to work it out together. I just wanted you to see the shape. So we're going to do some work over here. It's kind of small, 1, 2, 3, 4, 5, and then also like a sixth thing in here. And then there's going to be a bunch of tiny little lines. Okay, each of those lines is a slope. So each line gets the slope that your function would have at that point. Okay, you might notice in this particular example that all of these little guys have the same slope. Every single point here has the same slope. Every single point here has the same slope. Every point here has the same slope as each other. Okay, but all three of those columns have different slopes. Interesting. All these are the same. All these are the same. Okay, that's because as c is just a number, you just shift your graph up so that y-intercept changes. And you can kind of follow along with your slopes because they're slopes of tangent lines. If you just kind of follow along, you see that we get these little parabolas. So it's kind of neat. We're going to make one of those together. So don't pause and copy. Here's a clean sheet. We're doing the same problem. Okay, we want to find dy dx, the slope at each one of our points. To do that, we're going to find the x value and the y value of that point, and then we're going to plug it into this function over here, which is dy dx. Okay, so let's find dy dx at the point -2, +3, this point right here. Dy dx at -2, 3. That's the point we're plugging in. So everywhere that we see an x, you put a -2. Everywhere that you see a y, you put a 3. This does not count. Dy dx is like f prime of x. This is what you're solving for. So as we plug in -2 here for x, and there's no place to plug in your 3 for y, we get -2 minus 1, which is -3. And so I'm going to put equals -2 minus 1 equals -3. So dy dx equals -3. So the slope at -2, 3 is the slope -3, or -3 over 1, if you want to think about fractions. When does everyone want to think about fractions? Always. Okay. When x equals -2, we don't care what the y value is, do we? Because we're just plugging in -2. It doesn't matter if this is -2, 2. Doesn't matter if it's -2, 1, -2, 0. Every single point where the x value is -2, the slope is going to be -3. So we just found a pattern to save us from doing 1, 2, 3, 4, 5 more of those slopes. So when x equals -2, dy dx equals -3. And that's going to work for any y value. Y value. And that's because dy dx had no y in it. There was no variable y over here to plug in. So every y value for that x value is going to have the same slope. Okay, so that kind of goes with this. And the same thing is going to happen no matter what x is. That whole column is going to be the same. We saw that. The whole column is going to have the same slopes because it doesn't matter what the y is as long as the x is the same. Okay, hopefully we get that. You might want to reverse and watch that one little bit again. Here we go. Here's another one. We want to find dy dx at the point -1, 3. So I'm doing a system. I'm going across the top. I just did -2, 3. Now I'm going to do -1, 3. And then I'll do 0, 3, 1, 3, and 2, 3. Find a system and go with it. Don't just pick random points from your graph. So at -1, 3, dy dx equals, well, it's -1 minus 1, which is -2. So that is that slope. Let's do it again. Dy dx at the point 0, 3. So plug in 0 for x. This is 0 minus 1 equals -1. Dy dx at 1, 3 is 1 minus 1, which is 0. Slope of 0 is horizontal. And then dy dx at 2, 3 is 2 minus 1, which is 1. Okay, so that's our 1, 2, 3, 4, 5, 6 things we were going to write there. Okay, so all across that top line, the top row, all of those points, we're going to draw a teeny tiny little line, and it's going to have the slope that we just talked about. I'm going to start at the slope of 0. The slope of 0 means that we have a horizontal line, a horizontal tangent line. And we talked about how every single time x was 1, our slope is 0. Our dy dx is going to be 0. Okay, so every time x was 1, we have a slope of 0. So that's going to be these little guys. Every single time, all the way down. Okay, a slope of 1 is a 45-degree angle. I'm going to show you a 45-degree angle. If we take a piece of paper and we fold the corner in half, like so, fold it in half at the corner, that is a 45-degree angle, right? Because half of a 90-degree corner is 45. So a slope of 1 looks like this. A slope of -1 looks like that. Anytime you have a slope of 1 or -1 and you want to get really accurate, grab a corner of a piece of paper. Okay, we know that at 2, 3, our slope was 1, and at every spot where our x value is 2, the slope of that tiny little line is going to be 1. Okay, so column where x is 2, 45-degree. Just do your best. Nobody's going to measure your angles. Just do your best. Okay. When x equals 0, like at the point 0, 3, our slope is -1. So 45-degree angle this way. I think it's most obvious here. I guess I didn't do a very good job. That looks like a smaller angle than that one, but we try. All right, anytime that x was -1, our slope was -2. So that means we're going to have a steeper slope than -1. Okay, it's still a negative slope, but it is steeper. So I'm gonna just draw slightly steeper. You can kind of picture like moving down 2 and moving right 1 and connecting that line. This should be parallel to it. Down 2, right 1. That slope should be the same as this slope. Okay, and then -3 was our slope anytime x was -2. So think about moving down 3 and right 1. So our slope is definitely steeper than the previous columns. And there we go. There's our slope field. Okay, you are 100% more than welcome to watch other people's videos of this and see how they draw theirs as well. It's good to get an idea of a lot of different versions of equations. I'm going to go ahead and do another one. This next one on page 582 has x and y in the problem. So x's and y's are both going to affect our slopes this time. X's and y's. Okay, like I said before, I recommend finding a pattern and going with it. So pick like all of the x's that are the same number and just change the y's, or keep all the y's that are the same number and just change the x's, and just do a bunch of those. I'm going to go ahead and do black for x equals -2's. Let's try that first. I'm going to write up a bunch of these over here. So x equals -2. We want to find dy dx. Okay, so let's do -2, +3. That's the very first point up here. -2, +3. Then we're going to do -2, 2, -2, 1, -2, 0, and so on. So I'm going to write them all out. -2, 3, -2, 2, -2, 1. And our lowest is -2, -2. Okay, dy dx equals what? So we're going to plug in -2 for x and 3 for y. So this is -2 minus 3, which is -5. We expect that plugging in a different y value will give us a different number because y is in our equation this time. -2 minus 2 is -4. Negative 2 minus 1 is negative 3. Negative 2 minus 1 is negative 2. Hopefully we see a pattern. Subtract 0. Oh, I just copied my number. Negative 2. Oh my goodness, we're going to add 1 this time because subtracting negative 1 is like adding 1. So this is negative 2 plus 1, which is negative 1. And then negative 2 minus negative 2 is 0. So our pattern was that each of these increases by 1. Okay, let's go ahead and draw in some slopes. Our first slope is 0. That was at negative 2, negative 2, 0. Then we have a slope of negative 1, which was that 45-degree angle. Then we have a slope of negative 2. Then a slope of negative 3, slope of negative 4, and slope of negative 5. Okay, the big deal is that all of these are negative slopes, except for this guy, it's 0. And the slopes get steeper and steeper and steeper the bigger and bigger your negative number gets. Okay, let's move on to another one. I'll switch colors just so we got some consistency and we can see everything around us. Let's do dy dx when x equals negative 1. So we're just doing the next column. I'll zoom in a little bit. Okay, x equals negative 1. We want to find dy dx. So another way that I've seen these drawn out are like x, y, and then dy dx, like this. Okay. So all of these, the x value is going to be negative 1. 1, 2, 3, 4, 5, 6. We need 6 of them. 2, 3, 4, 5, 6. Our y values are highest at 3, and then they decrease 3, 2, 1, 0, negative 1, negative 2. I happen to be falling from like top down to the bottom. Okay, so 3 is our highest point all the way down. I don't know. I think it's easier to go top down on these guys because then this slope will be the top one, this one will be below it, and so on. Let's do this. It says x minus y. So negative 1 minus 3 is negative 4. Negative 1 minus 2 is negative 3. Negative 1 minus 1, negative 2. Hopefully we see our pattern. We're just increasing by 1 each time. So negative 1, 0, 1. So those are our slopes. At negative 1, 3, that point, our slope that we're going to draw is a negative 4. Let's see if we can find a 0 because then we can work from that. Negative 1 gets us 0. That is here. Okay, our slope at negative 1, 0. Zoom out on this guy. At negative 1, 0, the slope was negative 1. At negative 1, 1, our slope was negative 2. At negative 1, 2, our slope was negative 3, just steeper and steeper. And at negative 1, 3, our slope is negative 4. Pretty darn steep. Okay, moving back down, this slope is a positive 1, so that one's a little bit different. Cool. X is 0. If x is 0, this is 0 minus y, which is just negative y. So we're just going to make negative slope versions of those y values. Let's do it. 0, 3 would give you negative 3. It's kind of like 2 would give you negative 2. 1 would give you negative 1. 0 gives you 0. Negative 1 is 1. And negative 2 is 2. Okay, if you're struggling with like how slanty to make your lines, here's a suggestion. And this is what I've been doing. I've kind of been like looking for the rise over run. So for this example, our slope was 1. Our slope would be 1 over 1. So I just make it so that this points in that direction. And then I just make it a short line. For here, our slope was 2. So I go up 2, right 1, and then I just make sure that this slope points, and it's a little bit off, but pointed towards that 1 right there. So if you drew the actual line, it should go through that point. Cool. Let's keep going. Do we see a pattern? Hopefully the pattern that we see is as you move up in this diagonal line, we have 0 as our slope. This diagonal line has -1 as our slope, -2, -3, -4, and so on. So I'm just going to kind of follow that pattern and go with it. So diagonal, this is a 0. This is a 0. -1, -1. -2 is steeper, but not crazy steep. There we go. Okay, this diagonal line, the slope was 1. This diagonal line, the slope's going to be 2. So up 2, right 1 should be right about there. And this guy down to right about there. Okay, these guys will be 3, 2, 3, 1 points there. And then this guy will be a 4, just steeper. There it is. That's our shape. Cool, cool. So if you graphed the equation, like if you took the integral of this equation and then you graphed it, it probably looks something like really steep, less steep, then kind of mellows out and it kind of goes in that direction. So it kind of like, kind of weird. All right, next one. We've talked about some patterns. And we have a slope field and we have to figure out which one of these equations matches it. These are dy dx's, these are slopes. Okay, my suggestion is to find where is your slope 0. This, and use like process of elimination. This slope equals 0 anytime that y equals 0. So if you plugged in 0 for y into this top equation, you would get 0, right? X times 0 is 0. If you plugged in 0 for y in this equation, you would get 0. Perfect. Same thing, you get 0. This one, if you plugged in 0 for y, you would get x. So it is not D. Cross that guy off. Next one, E. If you plugged in 0 for y, nothing would happen because there's no y involved whatsoever. Remember when there was no y involved on that first page, the entire column was identical every single time because the y value did not affect it, but the x did. This guy has no y's. Are all of the columns identical? No, this one has positive slopes and then below it's negative slopes, so it's not E. But that like plug in 0 for y and see if it equals 0. It still works. Okay, so we've got 3 options. Let's try other spots where our slope is 0. This column, where x equals -1, our slope equals 0. So let's try plugging in -1. If you plug in -1 here, you'd have -1 times y, which is -y. That's not 0. No. B, if you plug in -1 here, you get -1y minus y. That's -2y. Nope. C, plug in -1 here for x. -y plus y is 0. Our slopes were 0. That's our only last option, so that's got to be it. Okay, you can test other spots, but the best ones to test are 0. Where are the slopes 0? And then just see if the x and y values actually make that work out. Okay, if you test out, it looks like probably we get 1 at 0, 1. So plug in 0 for x and 1 for y. We get 0 plus 1 is 1. Fantastic. We have one more page of this, and it's all an AP question. Oh, I guess we have a couple more pages. Anyway, this AP question, we consider this differential equation dy dx equals x to the 4th times y minus 2. On the axes provided, sketch a slope field for the given differential equation at the 12 points indicated. Use the axes provided in the test booklet. Right, when it's an AP test, they're going to give you a test booklet, kind of like the ACT, and everything that you write in that booklet will get graded. Anything that you do not write in the booklet will not get graded. So just make sure all your stuff is in the right spots. So for A, literally all you're supposed to do is this. It says 12 points. Count your 12 points. 3, 3, 3, 3 is 12. Sometimes there's like a missing set of points because it would, that set of points is not in your domain or range. I think that shows up on the next problem. All right, so we need to find slopes for every single one of these 12 points. Let's make that same like XY chart, but in a slightly different way. Let's see if you like this way. I'm going to put my Y values, which are 0 through 3, and my X values, which are -1 through 1. I'm going to make kind of like a multiplication table almost. We're going to get 12. So I'm going to make a 3x4 grid. So if the X's are -1, 0, or 1, and the Y's are 0, 1, 2, or 3. Okay, so I start with low down here and go up to high because that's what our like y-axis does. Then all the numbers inside, let's make those dy dx. Okay, our function is dy dx equals x to the 4th times y minus 2. And I kind of rewrite that over here. dy dx equals x to the 4th times y minus 2. I like plugging in 0 for things. Let's start by plugging in 0 for x. Now I've got a spot for everything. I know where all of my stuff goes. Plugging in 0 for x, we get 0. It does not matter what y is if this is 0, because 0 times anything is 0. So all of your little slopes are 0. If we plug in 1 for x, this just is 1. So we're left with 1 times y minus 2, so it's just y minus 2. Okay, we're going to plug in the 3. 3 minus 2 is 1. 2 minus 2 is 0. 1 minus 2 is -1, and 0 minus 2 is -2. So there's a lot less writing with this one than on that first example or the second example. Just make a little table. All right, let's plug in -1 for x. -1 to the 4th power is +1. So if this is +1, just like it was in this column, aren't these all going to be the exact same thing as these? Heck yeah, they are. 1, 0, -1, -2. Okay, then it's your job to draw all of these slopes on that grid. Okay, down the y-axis, like at 0, 3, we're going to have horizontal. At 0, 2, horizontal. 0, 1, horizontal. 0, 0, horizontal. We also have horizontal all the way across when y equals 2. Okay, our other slopes, when x equals -1 and y equals 3, our slope is +1. We also have a +1 slope here at 1, 3. We have -1 slopes here and here. And then we have -2 slopes, so that's just steeper than -1. Okay, this is as complicated as these graphs are going to get. They're going to give you like 12 points, and that's it. Okay, they're not going to give you tons and tons of points like those previous problems. We had like 1, 2, 3, 4, 5, 6 by 5. We had 30 points. That was a lot. All right, we just sketched the slope field. B, while the slope field in part A is drawn at only 12 points, it is defined at every point in the XY plane. Describe all points in the XY plane for which the slopes are negative. Where are we going to get negative slopes? Well, we discovered that when it doesn't really matter what x is, right? It doesn't matter what x is. If you plug in a positive number or a negative number, it's just going to end up positive over here, except if x is 0. Okay. So we can possibly have negative slopes. That's what we're looking for. Where do we get negative slopes? At any place except where x is 0. So part B, x cannot equal 0. That's a big part of it. X cannot equal 0. What else has to be true? Well, if this is positive, positive times negative is negative. So that means that y minus 2 has to be less than 0. Okay. This part has to be negative, so that negative times that positive, x to the 4th, will get you a negative number. So we're going to add 2 to both sides, and we get y is less than 2. Oh my gosh, you couldn't see a thing. Okay, so that second, that set of parentheses has to be less than 0. We add 2 to both sides, y is less than 2. Fantastic. Both of these things have to be true, because if y is less than 2, but x is 0, we still get 0 slopes instead of negative slopes. So that's all you really have to do for part B. For part C, find the particular solution, that means we have to solve for C, to the given differential equation with the initial condition of f of 0 equals 0. So we're going to take this dy dx, I already wrote it down over here, isn't that handy? We're going to take that dy dx equals x to the 4th, y minus 2, and we are going to solve to get y by itself. Okay, this is the exact same problem as a few pages ago in a different lesson. This was this problem over here. Okay, if you want to go back, go ahead. It's this exact same thing. We end up with 2 minus 2e to the 1/5 x to the 5th power. So this was page 577, number 5. So either you try it yourself, and then you should get that answer, or go back and rewatch that video. There's no point in me making that video again. All right, I'm going to jump over to the next problem, and then this is our last page. It's another one of these guys. Exact same problem type. So you can see that there's a pattern to the way that they ask these questions. We're going to consider this differential equation dy dx equals y minus 1 over x squared, where x is not 0. Oh my gosh, look, it's this exact same one again. So that was number 5 on the previous one. This will be number 6. So when we get to part C, no, part B is where it asks for if f of 2 equals 0. I'm going to refer you back to that one as well. Okay, part A, on the axes provided, sketch a slope field for the given differential equation at the 9 points indicated. So just 9 this time. I see 9 points. I do not see any points along the y-axis. That's because x cannot equal 0. And that's because if x equals 0, the denominator equals 0. Dividing by 0 makes the world explode. So not that. So we need the points. Let's make that little chart that I made on the previous one. We need 9 boxes. The x values are -1, 1, and 2. The y values are 2, 1, and 0. And all the little boxes are dy dx's. Okay, we are plugging this into dy dx equals y minus 1 over x squared. So kind of zoom in on that. All right, let's do a column. Let's do this -1 column. That makes your denominator equal +1, right? -1 squared is +1. So all of these denominators are going to be 1s. I'll write all those little fractions in there, fraction bars. Okay, -1 gives us +1 denominators. Now let's plug in 2 on the top for y. 2 minus 1 is 1. Next, 1 minus 1 is 0. Next, 0 minus 1 is negative 1. So we have 3 slopes. This is 1, this is 0, this is negative 1. Next, when x is 1, our denominator is 1 again. So that's that whole column. In the last column, oh, look, we can do all columns and then we can do all rows. Oh my gosh, this is so nice. So this is 2 squared, so our denominators are 4. And then this row, our numerators are all 2 minus 1, which is 1. In this row, 1 minus 1 is 0. And in this row, 0 minus 1 is negative 1. Kind of worked out nice because it was like top versus bottom kind of a thing. Okay. That reduces to 1, that reduces to 0, that reduces to negative 1. And those fractions on the right, I guess the middle one reduces to 0. But we got 1/4 in there. So those should be very shallow instead of very steep. Let's graph some points. For each of those points, we'll graph a slope. This top one right here is a 1 slope. That's a 45-degree angle. This slope is 0. This slope is negative 1, 45 degrees in the other direction. As long as your positives and negatives are correct, you're probably going to be pretty okay. So don't freak out if your slopes are like way too steep or whatever. Just do your best. Okay, second column, same slopes. 1, 0, negative 1. And last column, 1/4. 1/4 is positive, but it is not as steep as 1. So 1, 1, 2, 3, 4. It should be like, it's like barely more than 0. And then 0, and then negative 1/4 should be like a mirror image of that guy. Sweet. We've done part A. That's the graph. It's called the slope field. Part 2, find the particular solution. So that was part A. Part B is problem number 6 from page 577, number 6. And then C says, for the particular solution described in part B, find the limit of f of x. So I'm going to go ahead and grab that function that we had, which was f of x equals 1 plus e to the negative 1 over x plus 1/2. And all that was in an exponent. So part C says we're going to take the limit of f of x as x goes to infinity. Limit as x goes to infinity of 1 plus e to the negative 1 over x plus 1/2. Cool. What that means is, what's our right end behavior when this is our graph? Okay, so if x gets really big, what's going to happen to this fraction? We end up getting 0 for that. Okay, so if this is 0, then this limit equals 1 plus e to the 0 plus 1/2, which is 1 plus e to the 1/2. That's it. That's all you had to do. Plugging in infinity makes that denominator really big, so the fraction equals 0. And then simplify it. That's it. So as you go super far to the right, this is your limit. Fantastic. That's the last bit of this video. Have an awesome day.